Let's take a look at finding slopes of lines. But before we do that, let's review some definitions. The slope of a line is the ratio of rise to run. If x1, y1, and x2, y2 are any 2 points on the line, then the slope of the line is m equals y2 minus y1 over x2 minus x1. Well, you can also think about slope in terms of rise over run, where the rise is the difference in the y values of the 2 points on a line, and the run is the difference in the x values of the 2 points on a line. With this in mind, let's find some slopes. The first example we have line AB. And we're going to have to first determine the coordinates of that line. And we have 2 points. I'm going to put this up here so we can remember our slope formula. Point A, the coordinates of point A are 3, 1. Okay. And the coordinates of point B, 6, 3. All right. Using this slope formula, y2 minus y1, you know what I want to do now? I want to first indicate which is x1. Let's call this x1, y1. Okay? And let's call the second ordered pair x2, y2. Now let's substitute. We have, according to the formula, y2, in this case it's 3, m equals, which is slope, 3 minus, what's y1? 1 over, x2 is 6, minus, x1 is 3. Let's simplify. 3 minus 1 is 2, 6 minus 3 is 3. So we have 2/3 as our slope. And notice it is positive and it's slanting to the right. Let's try another one. Let's try CD. Once again, I'm going to put this up here so it will help us to remember our slope formula. We're wanting to find the slope of line CD. Well, the slope of line CD, we need to first identify some coordinates. For point C, we have 3 down 2, negative 2. And for point D, we have 3 and 1, 2, 3, 4, 5. 5. Once again, I'm going to indicate, let's call the first ordered pair x1, y1. x1, y1, and the second one, x2, y2. This is something I want you to remember. When you're identifying the ordered pairs, if this is going to be the x1, y1, make sure these are x2, y2. You can't go x1, y2. These have to be the 1s, and these have to be the 2s. Now let's go to our formula. In our formula, it says the slope is equal to y2, which is 5, minus, which is y1, which is a negative 2, over x2, which is 3, minus 3. What do we get? 5 minus a negative 2. Remember, you add the opposite, so that's going to be 7 over 0. But division by 0 is undefined. So our slope in this case is undefined. I want you to notice something. What kind of line do we have here? We have a vertical line. all vertical lines parallel to the y-axis, the slope is going to be undefined. That's something you may want to remember. You'll see it again. Let's try another one. Let's look at EF. I'll put this up here. EF, line EF, the coordinates for point E is 0, 5, and the coordinates for point F, 4, 5. Notice this is a horizontal line parallel to the x-axis. Let's call this x1, y1, x2, y2. Now let's use our formula. The formula for the slope says we subtract the y-coordinates. We're going to start with 5 minus 5 over 4 minus 0. What's that equal to? 0 over 4. But what is 0 over 4 equal to? 0 over 4 is equal to 0. So in this case, our slope is 0. Okay? Something else we need to remember. Any horizontal line parallel to the x-axis, the slope will always be 0. You'll see that again. And our last one, line HG. Line HG, let's identify the coordinates. H, for point H, it's 0, 1. And for G, it's 2, 0. X1, Y1, X2, Y2. Does it matter? Could I call this ordered pair X1, Y1? Yes, you can. Doesn't matter. But whichever way you begin, if this is going to be the X1, Y1, this has to be X2, Y2. Watch out for that. Now let's get our slope. Our slope is equal to Y2, which is 0 minus 1 over 2 minus 0. What is 0 minus 1? That's a negative 1 over 2. Notice we have a negative slope. Okay, it's a negative 1/2. We also notice that the line is slanting to the left.